Okay, next we will see what is pointer to pointer. Suppose there is a program like this. The main function contains the statement I star j star star k. So here I is an integer type data, then star j, that means j is a pointer to an integer type data, then star star k, it means k is a pointer to pointer, that means k can now hold the address of a different pointer. So now if I write this statement I equals to 5, then j equals to address of I, then k equals to address of j. Then if you want to print the values I star j star star k, so what this will print, first I, the value of I is 5, so this will print 5. Then star j indicates the content of the memory location that is pointed by j, so this will also print the value 5. Then star star k, this also indicates the same content, so it will also print the value 5. So if you run this code, then you can see that it is printing the same value 555. Okay, so this is the use of pointer to pointer, that means which can hold the address of a different pointer. So now we will move to structures. So first of all, structure is used to define user defined data type, and it can hold different types of data items. Suppose if I define a structure like this, here struct keyword is used for defining a structure, then the student is the structure name, so it can hold an integer type data role. It can contain a character array name, then it can contain a float data marks, like this. So this is a structure definition. Now this struct student becomes the data type. You can use this data type for declaring structure variable. So your main function can contain structure variable. So here a is a variable of struct student type, that means a is a structure variable here. Now to access the different structure members, these are called structure members. So to access these structure members, you can use dot operator, a dot roll equals to 3 suppose, then you can write a dot marks equals to 7.5, then you can print this also, %d %f, then a dot roll, then a dot marks. Okay, so um, like this you can access the structure members. Now, what is the size of the structure? Can you say what is the memory requirement for this structure variable A? For this, you have to consider the individual structure members. So here, int role, it is an integer type data, and you may know that an integer data takes 4 bytes of memory. Then there is character array. The maximum size is 15. So it will take 15 bytes of memory. Then there is a float type data, marks. A float data also takes 4 bytes of memory. So 4 plus 15, that means 19. Then 19 plus 4, that means 23 bytes. So if you now print the size %d, you can use %ld also, then size of a. So this will print 23 bytes. That is the memory requirement for this A. So but depending on the compiler, 1 or 2 bytes more are added. So if I compile, then run this code, you can see here the size is 24 bytes. That means the exact value is 23, but in GCC 1 byte more is added. So that's why it is coming as 24. Then a dot roll, that is 3, then a dot mark 7.5000. So this is the basic use of structure. Now there is one more thing that is used for defining user defined data type, that is called union. Here union student becomes a data type. So in your program you can use this for defining union variable. So union student A. Now A is a variable of union student type. So now what is the difference between structure and union? The first important difference is here the compiler allocates memory for the largest member. So if you consider the structure members, the members of the union, then here int takes 4 bytes, float also takes 4 bytes of memory, and this character array takes 15 bytes of memory. So the compiler will allocate 15 bytes of memory for this union variable A. And I have said that depending on the compiler, 1 or 2 bytes more are added. So in GCC it will show the size is 16 bytes. Now one more important point is here, only the last value can stay at the allocated memory. So first you have initialized 3 to a dot roll, then you have initialized 7.5 to this a dot marks. So the last value is here 7.5. So after this assignment, the previous value will be gone. So here when you print these two values, a dot roll and a dot marks, in this case a dot roll will have a garbage value, and a dot marks, that is the last value, that is 7.5, it will show, uh, but the previous value will be gone. So the point is here, the allocated memory is shared between the individual members. So here if you run this code, you can see, look, the size is here 16 bytes, 15 bytes, and in GCC 1 byte more, so it is showing 16. Then look, this a dot roll here it is showing a garbage value. Then a dot marks, that is the last value, so it is showing 7.5000. So these are the main difference between structure and union, as the allocated memory is shared between the individual members. So it is problematic to handle the union variable in your program. So we will get back to structure. So here one more thing is, you can use type def. Type def is used for creating a new data type. So you can give a name, short name for this struct student data type, that is a long one, right? So now you can use stu in place of struct student. So basically type def is used for creating a new data type and making for and short data type. So you can now use stu. So like this you can use the type def. So now here a is a variable of structure student. So next we will see how to access the individual members through structure pointers. Suppose there is star b. So now b is the structure pointer. So b can hold the address of a structure variable. That means you can write b equals to address of a. Then to access the individual members, you need to use arrow operator, b arrow roll. So it will be b right arrow marks, then it will be also b arrow roll, then it will be also b arrow marks. So like this you can access the individual members of the structures through structure pointer. For that you need to use the right arrow. So now you can take structure array also. So suppose if I take a structure array, then it will be like this. Suppose stu-a3, then you can take the values into it. You can write this statement, enter the info. That means this a can hold maximum of 3 records. So that means 3 student records. So enter the info, then you need to use the loop counter. One thing I must say that this double slash is used for commenting. The compiler will not execute these statements. So after this you can write for I0 I less than 3, then I plus plus, then scanf, then %d, percent s, percent f, then ampersand ai dot roll, then ai dot name. You don't need to put ampersand in case of character array, that means string. But remember, for this case it will not read the string with the full string with spaces. So ai dot name, then ampersand ai dot marks. So this is for taking the values into that structure array. So after that you can display these records by passing the structure to a function display. So you can pass this to a function display like this. Then you can now define the display function. So void display, then stu a. So next you can print the student records. So this is the entered info. So after this you can print the values. Printf %d, %f, %s, %f, then ai dot roll, then ai dot name, then ai dot marks. Okay, so this is the definition for this display function. It will just display the student records. So like this you can take a structure array in your program and you can pass that to a different function. Now you can use structure pointer also to represent a structure array. So here this you can take like this, stu star a. So now you will represent a structure array through a structure pointer. So for this you need to have dynamic memory allocation, right? So you need to write this statement, a equals to, then the type is stu star, so stu star. Then you need to use malloc, or you can use calloc also for dynamic memory allocation. Then the maximum size is 3, right? So 3 multiplied by size of this stu. That's it. It is required for dynamic memory allocation for this A. So after dynamic memory allocation, you are taking the values into this A, then it will be this ampersand, it will be this AI will be now A plus I, then dot will become right arrow, then ampersand A plus I right arrow roll, then it will be A plus I, then right arrow name, then it will be A plus I, then right arrow marks. Like this, you can take the values into this A. So after taking the values, you can pass this A to this display function. So here it will be star A, because you are representing the structure array through structure pointer. So after that, it will be AI will become A plus I right arrow roll, then it will be A plus I right arrow name, then it will be A plus I right arrow marks. Like this, you can use structure pointer to represent a structure array. The same thing you are representing through structure pointer. So here you can also use dot operator. So if you want to use here dot operator, then suppose you want to use here dot operator, so it will be like this. Then you need to put star of A plus I, star of A plus I dot marks. It can be accessed like this. This also indicates that particular element. So like this also you can access the individual members through pointer. So these are for structures. Now there is one more thing regarding structure, that is self-referential structure. So for self-referential structure, you can define like this: struct, suppose node, then int data, then struct node star next. So this is called self-referential structure because it contains one member that points to the same data type. So let's take one simple program. So suppose okay, so in this case you are using pointer, right? So here you need to use the header file stdlib.h. So now uh, here also you need to use that header file for dynamic memory allocation, stdlib.h. So this is the structure definition. So it contains one data item, integer type data, and it contains the address of the next node. So there is one type of data structure called linked list. Linked list. So this is the structure definition of a node in linked list that contains a data item and the address of the next node. That means this next contains the address of the next node which is of struct node type. Okay, so if I create a node of a linked list, then you can define the main function like this. So now you need to use struct node star. Suppose you want to create one node in a linked list. So suppose node 1, struct node star node 1. Then you need to have the dynamic memory allocation for this node 1. So you need to write this statement node 1 equals to, then the type, that is struct node star. Then you can use malloc. Then you need to use this struct node. Size of struct node like this. So it is just one node, so you don't need to put 1 multiplied by this because that is the same thing. So just you can put size of struct node. Then you can take values into this node 1. Then you can write node 1, then right arrow data, that will be one integer, so you can take 5. Then in the linked list the last node points to null. So here you are taking just one node, right? So this is the first node and last node. So node 1 right arrow next, it will be null because this is the first and the last node. So in case of linked list, the last node always points to null, so that's why you need to put here node next null. So this is for when the linked list you want to create a linked list that contains just one node, right? So if suppose the linked list contain 2 nodes, then you can use this star node 2. So then you need to have dynamic memory allocation for node 2 also. So it will be node 2 struct node star malloc size of struct node. Then node 1 data 5. Then this is node 1, right? So node 1 next, then node 1 next, it will be node 1 next, it will be the node 2, right? So it will be node 2, then node 2 data, node 2 data you can take as 10. Now node 2 becomes the last node, right? So node 2 next will be null. Like this you can create a linked list. So that's all for structure. Up to this point, this is your syllabus for this course.